is factor it. So factor it. Factor top and bottom. Factor the top and the bottom. Okay. Factor the top and bottom. Okay. We don't have to do that here. Okay. Second thing I want to make note of: after you factor the top and bottom, the factors that cancel are your wholes. Factors that cancel are your wholes or your removable discontinuities. Right? Do you remember what those are? That's when the function just disappears for a single point, right? Right? That's when the function disappears for a single point, right? Okay. Right? That's when the function disappears for a single point. Maggie, you hit the right light switch. Great, sweet. All right, that's when the function disappears for a single point. Okay. All right, so we didn't have to do that here, okay, so we'll just skip to step 3. Step 3, find your zeros. Find the zeros. How do I find the zeros? How do I do that? How? Concrete, yes.
Factor out things equal to x.
So you set what you have left, set numerator equal to 0. Solve. Just the numerator. Okay? Because you already took care of the things that canceled out. So whatever's left over, set it equal to 0 and solve for x. So here, we'll set what equal to 0? X plus 1.
You only do it for the top.
X equals -1. So my 0 here is -1. I have 1, 0. A single. Only for the top, for the zeros, yeah. Okay. What do I do after that? What do I do after that? What? I gotta find what after I find my zeros? Hmm? I'm scaring you to give me the answer. You gotta find the vertical asymptotes. Gotta find the vertical asymptotes. How do I do that? How do I find the vertical asymptotes?
Do you look at the leading coefficients?
No, that's end behavior asymptote. Good.
No,
Let's talk about the vertical asymptotes. Nope.
Oh, that's really good.
if it's top heavy, then it's 0.
You're on the right track for end behavior, not for vertical behavior. What do I do for vertical? Find the vertical asymptotes. So the vertical asymptotes are horizontal lines.
How do you find
Oh, you said you set the bottom equal to 0.
Yes, you said the denominator equals
I was
0.
thinking of base.
All right.
Sorry, I was
No, you're totally fine. All right, so here, x minus 3.
3.
All right, when I set that equal to 0, and, oh no, my Apple Pencil battery. So x equals. So that's our vertical asymptotes. That's our vertical asymptotes. Okay. Now Jade. What color should I use for end behavior asymptotes? Green? 5. You find your EBA, your end behavior asymptotes. Why am I calling them end behavior asymptotes and not horizontal asymptotes? There's 2 reasons. Right, in algebra 2 you probably call them horizontal asymptotes. Why?
No, wait, no. Now they can
2 reasons. There's 2 reasons I like the word end behavior asymptote, or the phrase end behavior asymptote better. The first reason is because the end behavior asymptotes, they're lines that your graph gets really close to but doesn't touch when you go to the end of the ends of the x-axis. So as you go to negative infinity, the graph gets really close to the end behavior asymptote, but doesn't quite ever touch it, right? As you go to positive, as you go to positive infinity, gets really close, doesn't touch it. In the middle near 0, your graph can cross the end behavior asymptotes, right? So I like to call them end behavior asymptotes because students can get really confused if I call them horizontal asymptotes and be like, why does it touch in the middle? Like, why does it touch that asymptote in the middle? It can do that, okay? It's not a horizontal asymptote, it's an end behavior asymptote, okay? Second reason I don't like to call them horizontal asymptotes. They're not always horizontal. They can be diagonal, oblique. They can also be oblique. Okay? So find end behavior asymptotes. What do I look at? What do I look at? All right, help Eric. What do I look at to find an end behavior asymptote? Someone help him out. So you look at the degree. Look at the degree of the top and bottom.
And then
You look at the degree at the top and the degree of the bottom. Okay? You look at the degree at the top. Who remembers what degree is of a polynomial, a degree of a polynomial? It's the highest exponent you see. Highest exponent for both the top and the bottom is 1 here, okay? So there's going to be 3 cases for end behavior asymptotes, okay? 3 cases. First case, the degree of the bottom. If the degree of the bottom is greater than the degree of the top, what's my end behavior asymptotes? What's my end behavior asymptotes in that case? Yeah, it's y equals 0. What if the degree of the bottom is equal to the degree of the top? Then what is my end behavior asymptotes? It's lead coefficient of top. You divide the lead coefficients.
It's equal.
If the degrees are equal.
So it'd just be a whole number?
Or it could be a fraction. Okay. What if the degree of the top is greater than the degree of the bottom? What do I do then? What happens then?
It doesn't exist.
Yeah, it does exist. It exists, but it's not horizontal, it's oblique. How do I find the equation of my oblique asymptote? So what you do is you divide the top polynomial by the bottom polynomial. Okay? And you just snip off the remainder. And then y equals that is, it'll be a line a lot of the time. It'll be a line. You'll see it. It'll be like a diagonal line. Result is, I'll say y equals result is your EVA. EVA. EVA Sports Syndicate. Okay. All right. There we go. Pretty good, pretty solid notes right there, in my opinion. In my opinion. For that one, why is it y equals 1, Maddie? Right, so the degree of the top is equal to the degree of the bottom. When that's the case, our end behavior asymptote we find by dividing the lead coefficient of the top by the lead coefficient of the bottom, okay? So here it's 1 over 1, which is 1. So here's our end behavior asymptote, okay? And then 6, the last step, I'm just going to say get your signs right. When you graph, get your signs right. I'll say plot. The last step I'll say plot the vertical asymptotes, zeros, and EBA, and get your signs right. End behavior asymptotes. It's a good question. So let's graph. Let's do some graphs. Let's graph. Okay. So what's my 0? What are my zeros here? I plot my 0. What's my 0? X equals -1. So -1 comma 0. All right. All right. Cool. What's my vertical asymptotes? I'll draw this with a vertical dashed line. 3. X equals 3. So let me draw that over here. Okay, x equals 3. What's my EVA? I'll use a red dashed line for that. Y equals, so I want to emphasize it's y equals 1, okay? For your end behavior asymptote, make sure it's a line like this. It's not vertical.
Can we just call it a horizontal asymptote because that's what we learned last year? Is that okay?
No. Yeah, I just want to make sure because, I mean, you can think of it in your own mind that way, but I want to make sure you know that
It's not touching.
it can touch in the middle, and then it's not always horizontal. It's not, your horizontal asymptote is not always horizontal. So you can think of it to yourself the way I'm going to say end behavior asymptote. Okay. All right, so we plot all those, then we want to make sure we get our signs right when we graph this, okay? Here's what I mean. Here's what I mean by signs right, okay? So there's going to be 2 places on your graph where the sign of the graph can change. What do I mean by the sign of the graph? There's going to be 2 places, so let me elaborate. 2 places where the graph can cross the x-axis. What are those 2 places? It's going to be at your zeros and at your vertical asymptotes, okay? Okay. Okay, so here's what I'm going to do. I want to make what's called a sign chart. And I want to see in this region to the left of my first 0. You look to the left of either your first 0 or your first vertical asymptote, whichever comes first, right? And you just plug in an x from in this region to the left into your original function up here, okay? So x plus 1 over x minus 3. Okay, I'm going to plug in -2, okay? I'm going to plug in something to the left of either my first 0 or my first vertical asymptote, whichever comes first, right? And I'm going to plug that into my function. I'm going to note the sign of it. So that's -2 plus 1. Right, so that's positive. So to the left of this first pink 0 here, I know my graph is going to be positive. Okay. I know to the left of that first pink 0 there, my graph is going to be above. It's going to be in this region, above the x-axis. Okay. Don't shade. Yeah, don't shade. I just write a plus and I circle it. And then I'm going to pick okay, after my first 0 then, I'm going to go to the next region, the region in between my first either 0 vertical asymptote and my next either 0 or vertical asymptote. So -1 to 3, plug in a value from there. I'm going to plug in 0. F of 0 equals 1 over -3, which is less than 0. Okay?
So that one's negative.
So we know between the pink point and the orange boundary, the orange dotted line, my graph is going to be below the x-axis.
So it's going to be like this.
All right. So, and I'm going to pick a point to the right of x equals 3, to the right of either my last 0 or my last vertical asymptote. Let's do 4. What matters is the sign. If you get the answer to like f of 4 wrong, but you get the sign right, you'll be fine. So that's positive, right?
How is that?
4 plus 1 over 4 minus 3.
But how are we even, why are we even doing up all the way up there? Because isn't it just easier? So it wouldn't even cross our class until.
Yeah, I mean, yeah, I think you're.
Like, you get what I mean? Like, when you plot.
It wouldn't cross the behavior.
Yeah, it's not gonna cross here, so.
Yeah, so I want to make sure, I'm trying to figure out if the last part of the graph looks like this, or if it looks like that.
Oh, yeah, because it reflects.
I gotta figure that out. Okay, so here's what's gonna go. So I know, I'm ready to finish my graph, okay? Okay. So I know to the left, so I know it crosses through this 0, and it does so from above, right? It's positive over here, and then it's gonna come and cross through this 0, okay? So it's gonna do that. Okay? And then it'll be negative in this region, okay? All right? As your curve gets closer and closer to this orange vertical asymptote, it's either going to go down forever or up forever. What's it going to do here? How do I know it's going to go down forever? It's got to be negative. It's got to be negative in this region, so it's going to go down forever. Okay? And then I know it's going to approach as my graph goes to the left forever, it's going to approach my end behavior asymptote from below. Okay, so that's that part. Doesn't look neat, but it's a good sketch. All right, it's not going to get the any art points here, but. And then to the right of my orange vertical asymptote, what do I draw and how do I know? So it's it's going to be, it's positive, right? So as my graph approaches my vertical asymptote from the right here, it's got to go up forever, right? If it went down forever, that would mean that I have to have negative here, but I don't. So because to the right of this vertical asymptote, I'm positive, I know as my graph gets close to the vertical asymptote from the right, it's got to go up forever instead of down forever. Does that make any sense? Okay. And then as I go to the right forever, I know I'm going to get closer and closer to my end behavior asymptote. So that's the answer. That's a good graph. Let me see. I think Miss White might want you to label the y-intercept. How do I find the y-intercept of a graph?
What do you mean?
How do I find where the graph intersects the y-axis? How do I find this point here? We know the x-coordinate is 0, and then whatever we plug in for 0, you plug 0 in for x, and we got negative 1/3. So it's going to be 0, negative 1/3. So label that y-intercept for me.
You do want to split one.
Good. That's a good looking graph. All right. Can I move on to the next one? Yeah. Okay. Okay. So first thing I do is what? Factor the top and bottom. Yep. So let's factor this guy. It's gonna be x plus 1 times x minus 1. All right. We should have learned difference of squares 3 years ago. So. Okay. So I factored it. Is there anything I can cancel? Anything cancel? Do I have any removable discontinuities? No, right? The factors that cancel, those are my removable discontinuities. Okay. I don't have any of those here because none of my factors cancel. Okay. Okay, now what do I do? What's my first step? Gotta find those zeros, right? How do I do that? Set the top equal to 0, right? So when I set the top equal to 0 and solve for x, what do I get?
Negative 1.
Plus or minus 1, right? VAs, my vertical asymptotes. What do I get? What do I do with my vertical asymptotes? I set the denominator equal to 0, and then I solve for x. When I set that denominator there equal to 0, oh gosh, what do I get? Get plus or minus 2.
What about this? The 2 out front. Yeah, 0 out front.
Uh,
No.
No, that's when that's a good. Yeah, it's when x is out in front. When there's a constant, because 2 can't equal 0. Yeah. I like that chain of reasoning though. I like that a lot. Okay, and then my EVA. What's my EVA? It's easier. Okay, it's easier to look at the unfactored form.
Should just be.
Y equals, so the degree at the top is 2, the degree at the bottom is 2.
1.
When my degrees are equal, I divide the lead coefficients, right? What's the lead coefficient at the top? What's the lead coefficient at the bottom?
1/2.
Yes, it's 1/2. Yeah. Yup. Now I'm ready to graph. How do we find the EDA? We divide because the degrees are the top of bottom. All right, so zeros. Plot those zeros out. -1, +1. Let's plot my vertical asymptotes. Cool. Let's plot my EDA. Okay, y equals 1/2. Okay. There we go. Sweet. Oh my goodness. Okay, so now I'm ready to graph. So I'm either going to draw it like this or like that. How do I figure out? If I want the black curve or the neon green curve?
Plug in something.
So I've got to plug in something to the left of -2 and see if it's positive or negative, right?
So can't we just make
So yeah, plug in -3.
3
So if you plug in -3, you get
8, 10.
you'll get 8 over 10. Yes, that's greater than 0, so it's going to be positive. Hmm?
I thought it couldn't go past the.
No, it does. To the there's going to be part of the graph to the left of the vertical asymptote.
Oh, okay.
Yeah, okay. So I've got to draw it like this because it's got to go as it approaches this orange vertical asymptote. It's going to go up forever, and so then I know as it goes to the negative infinity forever, it's got to go approach the red EVA from the top.
It's graphed like that.
What's that?
That's how it is.
Yeah, it looks like that. Looks like that.
So there's 2 sets of those. These are not those.
What do you mean 2 sets?
Like there's going to be 4 aligned right
You'll see. So in the middle here, middle's easier, okay? For the middle, it's either going to start positive, it's going to cross this 0, cross the other 0, then be positive again, because we know it has to cross both zeros. It has to cross both the pink points. Or it's going to start from below, cross the pink point, cross back. Okay. Go back down. We just got to figure out which. So how do we figure out which?
Do left of negative.
You can do left. You can do left of -1. You have to do -3 halves. It's
In
kind of a
between
pain.
1
You
and
could do
negative.
in between, right?
Can we just do 0?
Yeah. So plug in f of 0.
So -1 over.
You'll get -1 over -8, right?
Negative.
Which is 1/8, which is positive. So we know between these 2 pink dots here, it's going to be positive. So we know the graph's going to look like this. Right? We know it's going to look like an upside down horseshoe, all right? Because, right, so it's got to be positive in between the 2 pink dots, and it's got to cross each pink dot. It's got to cross each pink dot. Okay.
And then the y is on.
And then it's got to go down. Right? So we only had to plug in a point in between here because we know it's got to cross each one. Someone's definitely confused, which is okay.
I'm just confused. Wait, why doesn't it go up?
Why doesn't it go
It's like
up?
positive.
Why doesn't it go up
Yeah,
too?
no lie.
So it's gonna so we know it's positive here, right?
Yeah.
So this part you probably understand.
Yeah.
It's got to cross both the pink dots, okay? It can't go up again because for it to go up again, it'd have to cross this axis right here, which it can't do because there's no more zeros. So it's got to go down forever. We know it's not going to bounce off the zeros. For rational functions, I think it goes straight through each zero. Yeah, polynomials it can bounce off, but for rational it goes straight through. Let me confirm that with Miss White though. Okay, and then to the right of my last vertical asymptotes, how do I know what to draw? So I plug in a point, right? F of 3,
It's positive.
is it going to be positive? It'll be 8 over 10 again, right?
Yeah.
So I've got to go up to this vertical asymptote forever, so I'm going to come down to this end behavior asymptote. That's my graph. Yeah.
Are we gonna have another test?
Yeah, we're going to have another test next week. That's why we got to like Zoom. Yeah.
Or quiz?
Test. Ooh. Yeah, it's going to be a test next week. Tuesday. Test on Tuesday. Sorry. Thanks for reminding me to tell you. Yeah, test Tuesday. Yeah.
Crazy.
I got to stay.
Test or quiz?
Test. Take the AirPod Pro out, please. Test.
So there's no quiz this week. There's nothing this week.
I'm not doing a quiz this week. I might give it to you for practice. But test on Tuesday. That's why we gotta like whip through this. Because what's happening is we're getting to the end of the semester, and so we gotta make sure like we're all on track. It's in like not that long from now. It's in like 4 or 5 weeks. We gotta make sure we're all on track at the end of the semester. Because like if some people switch into Ford or white and you're like way behind, not good, not good. Okay, let's keep moving on. So we got to move to the other packet now. Are we good? Okay. All right, first step, we want to sketch this. Step 1. Step 1. What do I do? What's the first thing I do? All right, Caleb Martin, what's the first thing I do when I graph a rational function?
Okay, hold on. Wait, what did you say?
It's the first thing I do.
What?
When I want to graph this rational function.
Why is it set up like this?
No, you're forgetting one thing. Can I factor anything?
No.
No. Okay. So now, so finding the zeros. So the zeros. How do I find the zeros, Caleb? Zeros. How do I find the zeros? I set what equal to 0?
X minus 2.
I set the top equal to 0. For the top, for the zeros, I set the top equal to 0. X plus 3 equals 0. X equals negative 3 is my 0.
I swear we did.
What? Okay, Caleb, for the vertical asymptote, so what do I set equal to 0? Good job. X equals 2. Okay, for my EVA, Colleen, how do I find my EVA here? Yes. What are the degrees? Are they equal? Are they not equal? They are equal. So what do I do to find the EVA? Divide the lead coefficients. And it's a y equals 1. Y equals 1 over 1, which is 1. Okay, guys. All right. So let's go ahead and graph these. Let me plot my 0. I only got 1 0 here, unfortunately. Let me plot my vertical asymptote at x equals 2.
So we haven't even really started the actual problems yet. We're just doing this. still writing.
Yeah, we're just sketching it first. Okay. Start to the left of that, either your first 0 or your first vertical asymptote, right?
You still have to draw your UVA.
Oh my goodness, I'm so sorry. Completely, I don't know what's happening. Okay. I'm a monster. That's okay, I guess. It's acceptable. Okay, now I start to the left of either my first 0 of my first vertical asymptote here, right? So what's my sign to the left of -3? So if I plug in f of -4, I get -4 plus, oh gosh.
-1 over -6.
So f of -4 is going to be -1 over -6, which is greater than 0. So I'm going to be positive over here. I'm going to be positive, but I'm going to cross. So I'm going to cross that pink 0 from above, right? I'm going to go through that pink 0 top to bottom. Okay? And I'm going to be negative in this region. And I'm going to go down to that vertical asymptote. If you plug in a point like f of 0, you'll get a negative. Okay? And so then I've got to go up. I've got to go up to my EVA forever. I'm going to approach my EVA from below. All right.
So that's it.
Yeah. We good? All right. Yeah.
If I did this forward, did she had 0, -3 halves?
Oh, that's the y-intercept. So let's make sure we plot the y-intercept. How do I plot the y-intercept again? You set, f of 0. You want to plot f of 0. You want me to plot f of 0, so. So f of 0 is -3 halves. That's how she got that. She plugged in 0. Yeah, so I think I'm sorry, I keep forgetting to tell you guys to plot your y-intercepts. It's really easy though, you just plug in 0 for x. Okay, so let's connect these. Okay, then to the right of that vertical asymptote, is my graph going to look like this? Or is it going to look like this? And how do I tell? Top to the bottom one. What do I do? I plug in like a point to the right of 2, right? So I plug in f of 3. I get 6 over 1, right? Which is positive. Positive, so it's going to go up to this vertical asymptote from the right forever. And that's going to come down and approach my end behavior asymptote from the top. Okay. Okay. All right. So that's my graph. Let's fill out A, B, C, and D here. Okay. A and B. What are those going to be? The limit of f of x as x goes to positive or minus infinity. What's that going to be every time?
What?
I'm looking at A and B. Limit of f of x as x goes to infinity. Limit of f of x as x goes to negative infinity. What are these going to be equal to every time? Nope. So this is what my graph is getting really close to as I go to the left forever, as I go to the right forever. It's going to be the same as what?
X is less.
It's going to be the same as your end behavior asymptote.
So it's just 1?
If x is going to infinity or negative infinity, it's going to be the same as your end behavior asymptote. So 1. Okay.
So that's saying it can't equal that, though. It's saying it can't equal 1.
Okay, there's a definition for this. Okay, I won't give you the rigorous definition, but I will give you the colloquial definition, which is what that's saying is, as you go to the right forever on your graph gets really, really close to 1, but never touches it. It gets really, really, really close to 1. As I go to the left forever on my graph, this says as I go to the left forever, my graph gets really, really, really close to 1. Okay. All right. Let me think that the rigorous definition of a limit is to infinity is for all epsilon greater than 0, there exists a delta greater than 0, such that whenever x is greater than delta, like f of x minus the limit is less than epsilon, something like that. Okay, ignore what I just said. Okay, these. What's the difference, guys? What's the difference between A and B and C and D? What's the difference there?
There's a negative.
Now instead of infinity, it's a finite number, right? So for these, you look at your vertical asymptotes. They will either be positive or negative infinity. All right, Alberto and JJ, please stop talking. How do we know? So this 2 plus, what does the plus mean? Plus means from the right. The minus means from the left. Okay, so what this is saying is this part C here, I'm looking at part C. As x gets really close to 2 from the right, what does f of x go to? Does it go to positive or negative infinity? From the right of that vertical asymptote, does my graph point up forever or down forever? Up forever. So this is equal to positive. That's equal to positive. Okay? Okay. As I approach this D, part D here, right? This is saying, what does my graph go to as I approach the vertical asymptote from the left? Where does that go to? Negative. Good stuff. Good stuff. Okay, and now we're done with that problem. We're done so. Alright, we're finished. Okay. Alright, number 3. That's outside the scope of this course. Ask Mrs. Proponent. Alright, first thing I do. First thing I do.
Factor.
Yeah, can I factor this? No, so we jump straight into the zeros. That's the top, set the top equal to 0 and solve, you'll get x equals negative 1/2. So plot the 0, the only one. Only one. That's x. Vertical asymptotes. A what? Yes, at the bottom equals 0, so that's going to mean x equals negative 2. I'm trying to go a little fast here so I get through. I want you guys to see an oblique asymptote. For the x equals negative 2. And then what's my end behavior asymptote? How do I know? Y equals 2. Y equals 2, yep. Y equals 2. So let's plot my vertical asymptotes. Real quick. I want to plot my y-intercept. How do I do that? How do I do y-intercept?
Plus 0 for x.
Yeah. 0, which equals 1/2. Okay, so 0, 1/2. All right, so we start to the left of my first asymptote here. That's x equals -2. Am I graph negative or positive there? How do I figure it out? If to the left in this region right here, is it positive? Yeah, so if you plug in like f of -3, you'll get positive. Yeah, so I'm going to go a little faster. So we know it's going to go up forever at this vertical asymptote to the left of it. So it's going to approach my end behavior asymptote from above. Okay. Next region. So like f of -1. Am I positive or negative? Should be negative. Plug in f of -1, right? We're going to look at the region between my first asymptote that I just saw, and then my next either 0 or asymptotes right here. Yeah. I'll ask Miss White. I would guess no, because you can just graph it and calculate it. All right, so it's negative here, so it's going to approach this from the right. It's going to approach that vertical asymptote, going down forever. So then it's got to come up, cross my 0, right? It's got to cross that pink point. It's got to cross the red point, and then as I go to the right forever, it's got to get closer and closer to my end behavior asymptote. Okay. Okay about that? Then what are these? What are A and B going to be? At least, what are A and B going to be? 2. Yeah, they'll both be 2 because it's the same as my end behavior asymptotes. And then J, as I go, limit, as x goes to -2 from the right.
Negative.
Good job, yeah. All right, Madeline Shetty. Negative, as x approaches -2 from the left, where does f of x go? Yeah, good job. Yeah, okay, let's move on. I want to show you guys. Let's just go right. Oh man, there's a lot of examples left. Let's do 7. Let's do 7. All right, JJ. First thing I do when I'm graphing 7. Factor, good job. That's 3 and 1. Good stuff. Does anything cancel?
The 3,
No, nothing cancels. All right, so zeros, right? I set the top equal to 0, so my zeros are going to be x equals +1 and -3. Vertical asymptotes will be x equals -2. That's my VA. Fast. My EVA.
You go back to the original for the
EVA, you go back to the original. EVA, okay, what's the case here? What's going on here?
2 denominator bigger than
Why do you think it's 1, Elise? Are you dividing the coefficients? Yes, that's a good idea to do when the degrees of the top is equal to the degree of the bottom. Remember, we had to look at our 3 cases. That's on the other notes, right? What do I do when the degree of the top is greater than the degree of the bottom? What do I do to find my end behavior asymptotes? Divide and
divide top
ignore the remainder, right? So let's divide the top by the bottom. So 2, -3, I'm doing some synthetic division.
Why are we bringing
I'm dividing the top by the bottom. Would you rather do long division?
No, I'm trying to figure out.
Sorry, everyone. Sorry. Sorry. So sorry.
Wait.
Right, so if I divide it out, I get this result here is x minus 3 over x plus 2, right? So this is my oblique asymptote, except I ignore the remainder. So y equals x is my oblique is my end behavior asymptote. So let's graph this real quick. So plot your zeros. Okay. Do your vertical asymptotes. Do your end behavior asymptotes. Okay. All right. Plug in a point to the left of your first zero. Do you get a positive or a negative? You get a negative? Okay. Yeah, so you get a negative over here. Okay, so what you know the graph's going to do is it's going to come up and cross this zero from below, and then it's going to approach, it's going to go up to infinity as it approaches the first asymptote. And then as I go to negative infinity and x, like as I go to the left forever, the graph's going to get really close to my end behavior asymptote. Okay? To the right of that first asymptote, what does my graph look like? The positive or negative in the middle here. To the right of that first asymptote.
We have to plot the y-intercept first.
Yeah, sorry. What is the y-intercept? Negative 3 halves?
Yeah. So then it would be a
So it's going to come up,
negative.
cross, cross, and then get close to my EVA forever.
Or so it would be a positive. Yeah. Why did you do that?
Okay, finish 2.6. Does Ford have a good video of it? Okay, I'm going to post Ford's 2.6 and her 2.7. Finish the 2.6 and 2.7 notes, 2.6 and 2.7 homework. Sorry, it's a lot. We got to catch up. I'm sorry. Yeah, I'm sorry. We got to catch up.
Moving into grade
Actually, I'm not sorry. It's not my fault. Yeah, what's up?
Moving it like the test score. Moving it the test score.
Oh, what am I going to get them graded?
Okay. Yesterday?
No. Are you asking what I got? I'm sorry, Ian. Were you asking what I got them graded?
Like how you graded the test
No.
score. Yeah.
Oh, wait.
That me? Hey. Have your backpack? What? Dude, what? What are we reviewing for the quiz? Or are we?
I'm not giving a review day, but there's review sheets. You guys' quiz is Friday?
Yeah.
Here's this. I'll make this be Friday. Here you go.
Bro, he's not like compared to Dinesh, he's awful. He is. I don't want to lose myself.
You know what Brett's at? You know Brett's at?
What is that?
Which one is it?
Would it be like 23?
27 and 4.
Why am I desperate?
Really?
Why is there
Mitchell
this?
Adams is what, 22, We're in 6 probably?
What? You were the old or like, are they also kids?
They're like also kids.
It smells like
What? Right here.
Just for us, just for
Hey, Charlie,
Right.
have you ever
What?
will it just go up there?
Friday the summer. Yeah.
I don't know. And make sure we check those quizzes, okay?
Kristen, you want to get my card?
Yeah, it really is.
Oh shoot, we gotta turn off the video from last class.